welcome back. Welcome back. We're looking at P3 for Unit 19, and P3 needs us to produce an IoT system or a device designed to solve a problem, including the architecture, standards, communication requirements, and security. Straight away, we're going to define each term because, again, the person reading this might be a layperson who doesn't have any idea what any of these words mean. So let's define each term in the context of IoT. So Google search, what does architecture mean in IoT? Google search, what are standards in IoT? Google search, what are communication requirements in IoT? Examples of them. Google search, what does security mean in IoT? And this way you're going to have a nice first mini paragraph or 4 sentences, to be fair, it doesn't really matter. Once you have these defined and they're very obvious, so that when the non-IT, non-engineering person is reading this, the non-computer science person is reading this in the future, they can say, oh, actually, what does architecture mean again? And they can simply scroll up to the top of your document without having to go and Google anything from anywhere else, and they can see what architecture means or what it stands for. All right, so the architecture including the M, so we've done those 4 sentences now. Let's move on. So again, this is a mini introduction to this section. We've defined what we're going to be doing or defined the terms we're going to be using. Architecture is the first subheading, I would say. And again, I would use styles and formatting. As you guys can see at the left side of my document, I have headings for almost anything. This was a perfect example, actually. Let me just quickly show you what this does. So I have, let's say, 10, 20, 30, 40 pages, and I need to see something. I know exactly where P3 starts. I know exactly where P4 starts. So let's say I need to see the M, is there M2 criteria? I need to see the M2 criteria, and I need to know what's under the M2 criteria, or the thing I'm looking for could be there. I don't have to scroll through all the pages looking for the section I need. I can simply scroll down on the left-hand side, go to where it says M2, click on M2, and it takes me directly to that heading. So this is why I'm saying that you guys should ideally practice and make use of styles and formatting. I believe my first or second video showed you how to do that, so please go back and watch that one. So architecture again, the architecture including M2M system and device architecture, so machine-to-machine systems. We don't really need to worry about that term right now. It would be a good idea to define what M2M means or give a single sentence as to what M2M means, but it puts in bracket the stuff that we need to focus on, which is what I really like about this spec. It says including M2M system and device architecture, so we need to speak about the sensors, wired or wireless communication, actuators. So these are simply like stepper motors, DC, any type of thing that needs to move. It could be a robot arm, stepper motor, DC motor, it doesn't really matter. And device, network, and application domains. So simply what I would do here is speak about your device. Well, let me just get into it. So the device name is a Raspberry Pi Pico W, or we could also make use of the ESP32, the Wi-Fi version. This was created by the Raspberry Pi company, Raspberry Pi Pico W, obviously. And the ESP32 was originally designed by, I believe Arduino. They were like the first, one of the first mainstream, really big companies that blew up that dealt with microcontrollers for everyone, made it super, super easy, USB ports rather than serial ports and so on and so forth. State the name of your device, give some specs here of your chosen device. So I can tell you straight away some of my specs. I won't write it down, I'll just say it. Raspberry Pi Pico W, I might as well write it to be fair, 133 megahertz dual core processor. I believe it has 4 megabytes of storage or whatever it is. I think it has 128 bits of cache or whatever it is. State your specs here. I don't remember exactly what they are, to be fair, but I know it's a 133 megahertz dual core processor. So you go in and state your specs. Now that the specs that you state will give some indication of how well this thing will perform based on what you're trying to do. Because 133 megahertz, let's put that back, megahertz times 2 in theory is what I have. So roughly 266 megahertz processor. That is very, 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 very fast for a microcontroller. It's even overkill in most cases, but it's still tiny, it's still powerful, it still uses very little power. The sensors I've mentioned here are, I'm going to be using a motion sensor or an ultrasonic sensor or a laser emitter and receiver. These will be analog, except for the laser emitter and receiver. These will be analog and they'll be converted to digital. Say something along those lines as well. Communication, I'll be using Wi-Fi. well, my thing has access to Wi-Fi and Bluetooth, both normal Bluetooth and low energy Bluetooth LE. I do not have GPRS, but your device that you're using might have that for some reason. I don't have 4G or 5G. So for me, I'm going to be using Wi-Fi. You could say Wi-Fi and Bluetooth for using the Pico W, but for me, it's only going to be Wi-Fi. The network domain for me, LAN and WAN. That's what I'm going to be making use of. And again, I would give a single sentence or definition of what LAN is and what WAN is. So LAN is local area network, so the internet or the router connections that you have inside of your house, inside of a small office, inside of a building. LAN, local area network. And WAN is the internet, wide area network. WANs are made up of LANs. Let's not get too much into that. Do some research there as well. The standards are a thing that I don't know much about in terms of the professional standards that need to be included for this assignment. So it says standards including M2M interfaces and reference frameworks. Now, this is one of the standards I found on Google. You can go ahead and find many, many more. This is not something I'm going to be hung up on too much. A newly released comprehensive standard that provides guidelines on risks, principles, and control for the security and privacy of Internet of Things solutions. Have the risks been considered? If so, how have they been mitigated? Or how will you mitigate the risk? How will you lessen the risk? That's something you should know as well, or should put in your assignment. Give a couple sentences on this. Has privacy been considered? If so, how has this been, or how will you mitigate the risk of privacy being an issue? That's what I would put for that, to be fair. Now, I might be skimming over this very quickly. My apologies, but I don't think we need to focus too much on this. Communication requirements. Again, I'm going to skip this part here and jump straight to my part. Always on device to Wi-Fi once activated. Messages will only be sent once activity has been detected. It is not scheduled but instantaneous. So there will not be a thing that says I'm going to send a message every 30 minutes. No. My system is sitting there, always on, connected to the internet, to Wi-Fi, waiting for motion to be detected. Once motion is detected, it will send an email, send a text message straight away. That's it. I should probably add something somewhere that says I'll only send about maybe one text message and email every 2-3 minutes. If there's motion and it's been detected, let the person know. Don't bombard their emails or phones with text messages. Message priority will be set to high. This is a thing that can be done in Microsoft Outlook. I'm not 100% sure on how Google Gmail will do this, but I'll figure it out at some point. Messages will be text message and or email. I would say and email for now. And again, with Agile, I can always change this later on. If I'm not able to get both text and email working, I'll simply change it. A text file, not mugging, but logging date and time of each activation. And again, a data logging system is one that roughly sits there and just monitors what's going on and keeps a record or keeps track of everything happening. The IPv4 protocol will be used. The Raspberry Pi Pico does not and cannot make use of IPv6 unless you get another piece of hardware to do the translation. But IPv4 is perfectly fine because it's going to be on an internal network, and my specification or requirements did not state that I needed to access it from external network using IPv6. So just keep it at IPv4, everything is okay. And then the last one I have for this part is security. And I've said system will be unmanned, meaning there won't be someone there standing ready to turn it on and off every time. It's simply on all the time, and it has to be activated or deactivated. I've also said tampering or hacking is possible. Remote management not possible using this microcontroller. If network attacked device will not be able to transmit but will still have visual and audio capabilities. Encrypted emails by default, which means that when I send my emails, will be encrypted so nobody can get access to it who should not get access to it. Will only be sent to registered email addresses. Text messages will only be sent to registered numbers. So this is a section that was not on the assignment brief or on the spec. I think it's something that we should always have, and it's simply to describe system functionality. The system will only be activated at specific times or when the homeowners are not at home. You know what? Pause this yourselves and read it. This is like a mini pseudocode, which is me saying how the system is going to work. And it should be a case where it sits there always on. When people are leaving home, they flip a switch or they go on their mobile phones and they activate their home alarm systems normally, right? When you're going up to bed, it's 11 p.m., 12 a.m. in the morning, midnight, whatever the case is. You activate the alarm, you go to bed. So if there is movement downstairs when there should not be, you are alerted in some way, shape, or form. Now, for this one, it says that alert the homeowners when they're not at home, but I've just added some extra bits and pieces here and there. So describe how your system is supposed to work. Again, because this is P3, we're supposed to design, so we have to know what we're designing for. And this is what I would say. Pause that and watch that in your own time again. And I have here components. I've separated this into hardware and software. You don't need to do this because, to be fair, I could get rid of all of this here. It's not necessary. Hardware and software, reason being, again, if we're going to be designing, we're going to have, well, I'm going to have circuit diagrams, block diagrams. It's always a good idea to know what components are actually going to be used, not just for the reader, but for someone else who might want to design as well. So for hardware, I'm just going to list those quickly. Raspberry Pi Pico W, one micro USB cable, two LEDs, one green, one red, two 330 ohm resistors, and I give the code for the resistor value, one HC, and one motion sensor. That's all I'm going to say. Some jumper wires, very vague because I don't know how much I'll need yet. I haven't done the math on it. One single breadboard should be able to hold all these components, a computer with Windows, Mac, or Linux, and an active buzzer. An active buzzer, I think I did a description of why I needed it actually. Maybe I didn't. I would also maybe do at some point a justification of each component. Why do I need these components? I'll start from the bottom here. An active buzzer simply because it's cheap, it's easy to use, and I don't need an oscillator to make it work, where we have passive buzzers where I would need a voltage supply and an oscillator to make it work. So the thing that makes it go beep, 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 I can increase or decrease the pitch. Active buzzer, we don't care about that. You give it a DC voltage, 2 volts, 3 volts, it just works, and that's it. A Windows PC, a computer, it doesn't matter which computer, with a USB port, let's say that with USB port, because I need to connect my Raspberry Pi Pico via micro USB and USB-A to a PC to be able to program it. A breadboard in order to connect my components, so my LEDs, my motion sensor, my resistors, my, what else was there, my buzzer, some jumper wires to be able to connect components easily, so I don't have to do any soldering. It's a temporary way to make a circuit. It's an easy and nice way to prototype using a breadboard and jumper wires. With motion sensor, because it's probably the easiest, most sensible way to use this system. I did explain in my previous videos how I could use an ultrasonic sensor as well, or the laser emitter and receiver, but I don't have any of those right now, so I'm just using the motion sensor. Those cost on eBay about what, £1, £2, £3. So if your school needs to buy motion sensors, they're pretty decent, pretty cheap. Two times, so I'm going to need two of these components. 330 ohm resistors. I could do the math on this, but I'm not going to bother with that. I know that 330 ohm resistors are pretty decent for LEDs. They won't be as bright, most of them, but they should keep it more than okay in terms of safety. Two LEDs, one green, one red. It doesn't matter the color. I just chose green and red because I have those on hand. Reason being, I want, when it's flashing, there to be alternating colors, so it's very obvious that there's a flash. So if you have green and red going on, so green on, red off, red on, and so back and forth, back and forth. So it's very obvious to the person who sees it, okay, there's something going on there. I should probably go and check what's going on. A micro USB cable that needs to connect to the PC, because the Raspberry Pi Pico W is connected to the PC using a USB cable. It needs to be programmed that way. And finally, the Raspberry Pi Pico W, because that is the microcontroller I have decided to use. You could use ESP32. You could use Arduino. And I think there's a new Arduino out now, Arduino, Arduino R4. That one looks really, really nice. Actually, it has Wi-Fi built in, Bluetooth built in, and an LED matrix, not LCD, LED matrix. And a matrix is simply like a grid. Maybe I think it's like a 4x4 grid, a 5x5 grid. Doesn't matter. This device is really cool. I might get one at some point. Okay, I believe that's everything for that part. Now I'm going to jump into block diagram, pseudocode, and flowchart. So I'm going to do a separate video for these because I want to show you guys step by step how to do a block diagram. It's super, 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 super easy, but I still want to show you guys